the next speaker, I'm very excited to introduce you to Mr. Jürgen Kleinwächter. Mr. Jürgen Kleinwächter came to Portugal already many years ago, and he told me he started already in 1971, so that means 43 years ago, when I was born actually. He started to look at solar energy and is very busy with multifunction of solar, selective envelopes. So he's going to speak about his huge experience. So welcome very much.
Thank you very much. Good afternoon. First, I want to thank organizers for this excellent conference. I'm not an expert of passive house building, or I was not. I learned a lot. I'm very impressed. And thank you also for inviting my dear friends from Tamera. As you know, I'm not living in Tamera constantly, but we have together a solar platform in which we produce, I think, interesting things. So to say it again, I'm very impressed by passive houses, and please don't be offended if I am coming with some ideas which may not look completely passive. And all started when we looking to develop multifunctional solar systems being stimulated by the nature. Because what we believe is that if we look to the biosphere and to our planet, the strongest force, of course, is the solar radiation coming in, and in interference with the biosphere during the last 4 billion years about, wonderful systems had been developed. And if you really look to them, they are always multifunctional. So one day I started thinking about Godfather as being an architect. And I discovered that about 2.5 billion years ago, the first house was invented. This was a very tiny house, but it's the base of our life. It is the biological cell. You could say, as a general principle for architecture also, you build envelopes. We spoke a lot about envelopes here. And these envelopes, they have to shelter something very precious interior, which is, in this case for the architects, human life, which in the case of the biological cell were mitochondria, DNA, organelles, and so on. So looking at the principle of such an envelope, you can discover that this is not a rigid envelope. It is a system with selective transparency for different inputs, radiation, of course, also spectrum, oxygen, and also barrier at a certain time. And it's not fixed in time, it is controllable, and it is according to the needs of the interior changing every time. So please, all architects here, forgive me this little cynicism when I say, I take a German architect, if a German architect would have been at the origin of developing the cell, we would be all dead. So what, by looking to this, coming now more to practice, our target was to combine energy production and food production in one footprint. Therefore, our envelopes were technical filters with variable characteristics, because the fact photosynthesis requires about 20% only of the input radiation in a certain spectrum, so-called PAR spectrum. So 80% should be used as technical energy. Therefore, we build shelters, envelopes, which are extracting first technical energy in terms of heat, of electricity, of cooling, and let go to the interior of the envelope just the light which is required by the plants. So we built in Tamera, and if you are going to visit Tamera, you will see such greenhouses. And we could show that it's possible to have much better plant production and having energy at the same time. So it's quite evident that if the same principle could be applied for houses, we would not only then rely on the wonderful principles of the passive houses, which are necessary, but we would add something. We would not say, first we have to shelter to minimize the thermal need of a house, which is very important. At the second time, we want to extract maximum of energy. Let's take a fact of Germany. If in Germany we count the existing south-oriented roofs, and if we would, with the technology of today with photovoltaic, and if we would have the storage, if we would extract this energy correlated with the solar input in Germany, we would have, with these houses, 8 times more energy than the total energy requirement of Germany. So combining it is something we want to do. Therefore, of course, we are not jumping here, because one thing is clear, evolution taking step by step, taking place step by step. So the first thing, in a little movie, we want to show how existing passive house, which is equipped with, and we call it an envelope, greenhouse cloud, winter garden, could work. So please, let it go. So schematically, we see winter garden here. We see the winter garden. We see the sunlight falling on it. I will explain a little bit more later how we are filtering this radiation. A little part is coming in because, as you know, if you have full sunshine, you have about 100,000 lux of radiation force, and you need only 2,000 lux maximum for our eyes. So if you have 2% of transmittance, the rest is changed into heat in this case, and the heat is going into a storage. And then we develop together with Tamera very novel types of low temperature Stirling engines, which are already capable to run out of the heat of 80 degrees to 150 degrees centigrade and produce day and night electric power, and at the same time, as a cogeneration system, of course, all the heat which is required in such a house, which is symbolized here. Of course, as I will explain a little bit later, we can, such an envelope, I think now we are coming with a little picture. You see here schematically evacuated tubes which have a U value which is better than all the isolations you describe, but which have in interior movable elements. And these movable elements are the producers of heat energy. You can produce heat at 150 degrees centigrade, pressurized hot water, 5 bar with 50% efficiency. And some of them are photovoltaic, to kept directly when there is enough sunlight, sun to produce electricity. The weak point of the photovoltaic is the storage, as you all know, in terms of cost. Therefore, what happens? The movie is finished. Therefore, the combination of a thermal system which stores the heat coming out of such an envelope in low temperature heat, which is transforming it day and night into electricity, into cooling, in whatever you want, and taking advantage daytime from the very low cost of photovoltaics of today is a good approach, and at the same time shifting and turning these lamellas is exactly controlling the amount of light you need in. Now we are going to show, I think, okay.
Yeah, let's move in.
You see, let's go to the Stirling engine.
Okay.
Of course, such things can be built as pergolas for plants and so on and so on. Here you see just from the lab an example of a low temperature Stirling engine, which is run in this case out of the heat with only 80 degrees centigrade of the factory in which we produce it, and is pumping water. So the design point is 150 degrees, and then we have such engines in the power range between half a kilowatt and 2.5 kilowatt at the moment. Stirling engines are very simple engines, and we developed them to be capable to work already at very low temperatures. They are simply filled with ambient air and have two heat exchangers, one heat exchanger from where taking care of the heat of the hot storage, and the other one is the cold heat exchanger, which is then delivering the hot water to the house. With Tamera, we are bringing such systems into the platform, and we are looking for industrial contacts to produce it locally in Portugal in this case, but also in many other countries in the world. So, the thermodynamics, if you speak about Stirling engines, are excellent because this is a so-called reversible, practically ideal thermodynamic engine, and especially if you build it with low pressures, relative low frequency, you reach nearly the theoretically possible Carnot efficiencies. Therefore, they work at efficiencies better or equal to best solar cells, but at the same time they deliver the heat, and they can run day and night time out of storages, of simple heat storages. Okay, what are we showing now?
We can go for the PowerPoint.
Okay, how many minutes I still have? 15, okay. Fine. So I'm not going to bore you with too much details, but just to tell you, our envelope and your envelope are brothers. Only in our envelopes we have movable parts taking care of the light flux. And if you can build economically, that's what we discussed, if you can build panels which are vacuum isolated and which meet the price target, and that's what we are doing, and you control the light, again, please imagine you have full light, maybe you have a roof like this, or you have a wall like this, you close nearly completely your lids, automatically you extract all the energy, because you have the highest absorption surface, and you let just so much light coming in as you need, 1 to 2% for our eyes, you have natural daylight. If you are coming then to diffuse radiation conditions, cloudy, of course, since the level is much lower, the energy level, then you open more. And just one thing I want to tell you, our main emphasis on this is to develop internationally with specialists in the aquaponic systems, which is fish and vegetable production, shelters in which we can show that we produce on a footprint of less than 20 square meters the food and the energy for one person. And remember, today you require for the food about 4,000 square meters per person a day. So we can step by step think to bring this around passive houses, as it was described, and produce also our food. And again, if we look into the German Energiewende, it was said this morning by one of the people speaking. He said the big companies are starting in a central way to control the Energiewende. And this makes it very expensive because we need a lot of grids, we need super storages to compensate the fluctuations. If we can come with such type of systems, general class I described, into individual homes, then we can get rid from the dictatorship of the very big companies. So autonomy is our target. Okay, so let's go a little bit in pictures we can see here. I'm not going here, just explaining. So what we say, we have a filter. This filter let pass through the light we require in a variable way, and we extract out of it all technical energy needs we need. Next one. And of course, light is something wonderful. And up so far we just spoke about 1 kilowatt incident radiation, but if we are going into the spectrum, then we can start doing really wonders. First of all, we have to diffuse the light, which is much better for plants and also for humans, the glare in our eyes. Here. So we have diffusers in our filters. Next one. Here it is shown how we can put it into greenhouses in a schematical way. Next one. Here we see, we spoke about the pizza oven. We are just planting in Australia such a 550 square meter envelope power greenhouse, how we call it, on the second floor of an existing industrial building. And since we have the heat in our storage, the heat is not only useful to produce via thermodynamics electricity or power, it is useful for cooking and for baking. So we have shown, it's very interesting, if you take such a storage, about 10 liters of the storage, between the 200 degrees we go maximum, and the 100 degrees, which is usable, they provide about 1 kilowatt hour of heating power. That means as much as 1 kilowatt electric plate, 1 hour. So in a storage of some thousand liters, you can cook for hundreds of persons, and even a pizza oven. I would like to do this. Next one. That we have shown. Okay, I think this we have seen. In our little platform in Germany, we show all these principles, different envelopes. Show next one. And yeah, and we say, if we, it was stressed, the intelligence of the human race, which I'm not so sure if it's a general modus, because if you look how the development takes place, but for sure, for all persons here, we can attribute, and what we heard is, if we combine ideas, if we start from a solid base, like the passive house, which is certainly wonderful, again, but if we add step by step such elements with our fantasy and adapt it locally, that was the principle of the nature, to be adaptive. This is cybernetics. We come to cybernetic systems. So, last dream, you said you were considered as visionary, and visionaries in Germany, we had the chancellor who said, if you are visionary to the other chancellors, it was Schmidt to Brandt, to Willy Brandt, you have to go in a fool's house. But we know that's not like this. So, imagine, inside of an envelope power greenhouse with living persons like us, architecture with two rooms. An outer envelope with all these controlling devices. Inside, in-house, one of your passive houses. Then you go out of the passive house, you are surrounded by plants. And the controller of the whole is the plant itself. Because the plant, when I say it utilizes 20% of the light energy, this is typically speaking as technician or physicist, but nature is much more refined, it's changing every moment. Sometimes it's 18, sometimes 22, sometimes 15, sometimes it needs a little bit more red light, sometimes a little bit more yellow light. So plant sensors are developed, which even in Italy, we have an Italian plant sensor. From where was it, Maurice? From Damanhur, if you know this. You put it on the leaves, the leaf tells you what it needs, you translate it digitally to signals, the digital signals interact with the technical system, opens the filters, close it, and do all. So this, I hope I can see some of this during my lifetime, and I thank you very much for your attention.